Now, section 1.8, complex numbers. Now, we will see first complex number terminology and operations with complex numbers. Now, first we need to define I. I is square root -1. So I is called imaginary unit number. So I is not a real number. So the idea is this, like when you take the square of I, you will get -1. And there's no real number satisfies this property. So we can say I is not a real number. Okay, I is not a real number. And one other property is the square root of -a. A is a positive number here. So A is positive here. Okay, it might be 0 also. We have this property, square root of -a is equal to I times square root of A. So let's look at this example and let's try to find the square root of a negative number in terms of I. So the answer should be with I. So by using this property here, we can say this one is I times square root 16, which is for I. And then the other one is square root 12I. So, and if you want to simplify it, so you can separate these two, and you'll end up with square root 4 times square root 3, and square root 4 is 2, and we'll end up with 2 square root 3I. You don't have to write the parentheses here, you can write just square root 3I. And when it comes to here, this is 24 divided by square root 19, square root 49. And then you can, okay, I is taking care of this negative. And here for this part, we try to simplify it. And then you can separate, you can distribute this radical sign to top and the bottom. And you get square root 24, square root 49. So if you do the simplification here, like 4 times 6, it will give you 2 square root 6. So you will get this one. And this is 7, so you get this answer. Now, so in complex numbers, okay, this is a, we will use a plus bi. So when you see this type of number, a plus bi, you say it's a complex number in standard form. So this is a real number. Okay, by the way, this is a real number. And this is a real number. Okay, a and b are real numbers here. So this part is called real part of the number and of the complex number, and this is the imaginary part of the complex number. So let's see some examples. So 1 plus 2i, the real part, the imaginary part. Okay, it's better you take it with the sign. So 2 is the real part here, and 2 is the imaginary part, and 2 over 3 is the real part. But here, negative square root 3 is the real part, so you take it with its sign. This is the imaginary part. Imaginary, okay. And sometimes, okay, in standard form, yeah, we have this real number here, real part. This imaginary part here is -1. Okay. And some related notations and definitions. Okay, if b is not 0, we will end up with a number a plus bi. So we call it complex or imaginary number. And if a is 0, so we end up with a pure imaginary number. And if 0, I mean, if the imaginary part is 0, so we say it's a real number. So here, what does this mean? This means every real number is also a complex number. Yeah, or accepted as a complex number. So 0, you can write it as 0 plus 0i. And conjugate is a plus bi. The conjugate of a plus bi is a minus bi. So in the same way, if the conjugate of a minus bi is a plus bi. So you just change the signs here. And we will call them conjugate complex numbers. A plus bi and a minus bi are conjugate complex numbers. Now, identify the real part, the imaginary part, and the conjugate of the following numbers. Okay, let's see. This is obvious. This is real part is 1, and the imaginary part is 1. Here, 1 plus 1. Okay, you don't see anything. It's just 1. So the conjugate is 1 minus I. And here the real part is 1. So you can, to answer this question correctly, you can write it in standard form, 1 minus bi. You can change their places. So you can change the order. So you will have this one in standard form. So this will be the real part. And this minus 1 will be the imaginary part. And the conjugate will be 1 plus I. So you will see now. So I recommend you write this way, 1 minus I. This is plus coming to you can change their places, their order. So this is in standard form, A plus B type. So then you can say 1 minus 1 and conjugate 1 plus I. Now for 7I, so the real parts, you can leave this one as 0 plus 7I. So from here it's clear the conjugate is negative 7, imaginary part 7, and the real part 0. And here 3, you can write it as 3 plus 0i. Then the real part is 3, the imaginary part is 0, and the conjugate is 3 again, because when you write here 3 minus 0i, it's again 3. Operations with complex numbers. We have to keep one thing in mind. The only thing we have to do is to keep in mind that only like terms can be added or subtracted. Let's look at here. So when we mean only like terms, we mean only the reals with reals and the imaginary part with the imaginary part. So when you add these two, you add, okay, so it says perform the indicated operation, write the answer in standard form. Now, you add them. So it means you add the real parts with the real parts and the imaginary parts with the imaginary parts. So this will be 2i and this will be 4. So then the first one, real part, imaginary part, so it's in standard form. Now let's look at this one here. Of course, the subtraction rules and parentheses, it works the same way. Minus, minus 5, minus, minus, plus. So we have 3i, so this 2 will make 2. These two will make plus 4i. So this is the answer. Now let's do the try and check here. Okay, you can stop the video and try to do it by yourself. So I will just write the solution to you, like 4 minus minus 3, it will be 7, and 5i minus I, it will be 4i. Now, when we look at here, we will end up with 4 only because I, negative I, and I, they will cancel out and we'll get 0i here. So you can write it as like 4 plus 0i, or you can just say 4. In multiplication or division, we have to keep one thing in our mind. So the one thing is I squared is -1. So when we have I squared, we will change it to -1. And in division, we will write the division as a fraction, then change the denominator into a real number. Okay, we will see that. Now, again, here the usual multiplication and distribution rules are valid. So it's like 10, and then minus 5i, then plus I times 2, and then plus I times minus I. So when you write them, you will see 10 minus 5i plus 2i, and I times I squared, and minus plus minus. So what is this? So we'll write this one as, okay, this becomes, okay, I minus I squared is equal to minus 1. It becomes plus 1, as you see. It's this. So then we'll combine the real parts and the imaginary parts, and it will give us I11 minus 3i. So let's do the other one. Now let's see this. 1 times I, 1i, 1 times minus 5, okay, minus 5i, minus I times I, it will be minus I squared. And we know from the previous calculation, minus I squared is equal to minus 1. So it will be plus 1. So here we'll write plus 1 here. And then minus I times minus 5i is plus 5i. Then let's change it. Okay, let's change I squared minus I squared to plus 1. And then when we combine the real parts and the imaginary parts, then we will have minus 4 plus 6i. Now, let's do this, try and check. Let's calculate these. Okay, stop the video and try to do it yourself. And it says write the result in standard form, by the way. Okay, 5 times 2, 10. 5 times minus I, minus 5i, minus I times 2, minus 2i, and minus I times minus I plus I squared. So this is 10 minus 7i, and then plus I squared is minus 1, and then it's 10. Okay, you can write it this way then. What is this? This is 9 minus 7i. Now let's do the same thing here. 1 times y, it makes 2i. 1 times minus 5, minus 5. Minus 2i times minus 2i. Okay, let's do this. Okay, minus 2 minus 2, minus 2 to minus 4. I times I squared. Minus 4i squared plus 4. So this has to be then, okay, I will write this one first here for I squared. Then I will change it to plus 4i later. And then minus 2i times minus 5i, it's plus 10i. Okay, 2i minus 5. What is this? This is, we calculated already, it's plus 4 and I. Okay. Now we combine the real parts and the imaginary parts. And then let's combine the real parts. Minus 1. Let's combine the imaginary parts. It's 12i. Okay, this is the answer then. So these are the final answers. Okay, now let's come back to the conjugates. We have seen this. If a complex number is a plus bi, then its complex conjugate is a minus bi. And we will, okay, sometimes we use this bar here, z bar, for the, if we call this one z, so its conjugate, we will call this z bar. In some books, you will see it this way. So conjugates, these are the conjugates of each other. And we have a good property of conjugate numbers. So when you multiply two conjugates, two complex conjugates, you end up with a real number. So a plus bi, a minus bi. Remember this. This is like x plus y times x minus I, y is x squared minus y squared, right? So this is a, this is x is a, and then y is ib. Now, how do we end up with this plus here? Okay, you can see that it's ib squared is I squared, b squared. This is minus 1, b squared. This is minus b squared. Now, with this minus, it will be plus. So for this reason, it's plus. There's minus coming from here, and there's one minus here. It becomes plus. So this is a nice property, and we will use it. Okay, I'm sorry. So first, we will use it here in dividing complex numbers. So write the quotient in standard form. So we'll write this one in quotient form. First, let's write the equation. Let's write the let's write the expression here, the rational expression. And then the second thing is we want to get this one a real number. So one thing is to get a real number at the end, it's better to multiply it with its conjugate. What is its conjugate? 2 plus I. So its conjugate is 2 plus I. So we multiply the fraction, the top and the bottom of the fraction by 2 plus I. So this is mathematically it's equal to 1. So it changes the appearance, surat, but it doesn't change the mathematical value. So you can do this, the multiplication and distribution, and this is automatically, you can directly say this is 2 minus I times 2 plus I. It's automatically 2 squared plus here the imaginary part is 1I, 2 minus 1I, 2 plus 1I. So you can use this formula directly. It's 2 squared plus 1 squared. Or you can do the multiplication and see it yourself. Okay, then we'll end up with a real number in the denominator, which is 5. So then the next thing is this is not in standard form yet, so we have to do separate them into real and the imaginary part this way. A plus bi, standard form. Let's do this try and check exercise. So write the quotient. The quotient here means like the fraction. You can take it as a fraction. Okay, so it means this. To write the quotient in standard form. So do the division and find the quotient. So find the result of the fraction. We can say result of the fraction or division. So the result of the division is called quotient. Okay, I think the first we need to change this one to I. So you can say this is I times square root of 8. And if you do the simplification here, square root of 8, you can do square root 4, square root 2, and this will be 2 square root 2. And you can say this is 2 square root 2 I. Then the next thing is, you can do this simplification at the very end, so no need to hurry, but I would recommend changing this one to I for sure. So then first we write 1 plus 2 square root 2i divided by 2 plus I. So then we want to change the denominator to a real number, so as we multiply it with its conjugate, and we do the same thing to the numerator, and we will do this multiplication now. The the numerator becomes this, and the denominator becomes this product. Okay, let's do this multiplication here. You can do this multiplication it's equal to 5. Or if you are really good at this, you can directly say, what's the real part of this? It's 2, and the real part, the imaginary part, is 1. So you can say this product is equal to 2 squared plus 1 squared. So it will give us 5. This 2 squared plus 1 squared is coming from the product, as we did. Okay, now let's do the numerator. Two minus I, 4 times 2 square root of 2i, and then the last one is minus 2 square root 2i squared. Okay, now this becomes we put, okay, this is a real number, this is another real number. We can put them this way, like we can, this is minus 2 square root 2 minus, which will be plus, so I will erase this one and put plus here. So we can put them together first here. It's real part first, then the imaginary part. So in the imaginary part, when writing it, I will write it this way. I will take I out. So I is a common factor here. Then I will write the rest as minus 1 plus 4 squared 2. So in this case, I will separate them because it says write it in standard form. So standard form is like a plus bi. So I will write it as 2 plus 2 square root 2 divided by 5 plus I times, I can change their places also. So when you pay respect to their signs, okay, like when changing the order, there's no problem. And also at the end you can erase this, put this I here. So this is the standard form. Yeah, this sometimes the numbers in science and technology turns out bad. It's very normal. In mathematics we deal with very good numbers, but this might happen. Anyway, thanks for watching. That's the end of it.